we're doing more with identities today. You're actually going to be verifying some identities today. Even though when I did the notes, I didn't realize that. So first period, I was like, whoops. We made a couple changes. So today's 25th. We talked about the identities yesterday, the big ones. What are the quotient identities? Tangent theta equals sine over cosine. Very good. Which means cotangent is?
Cosine over sine.
Cosine over sine. Very good. Quotient identities, really important. Pythagorean identities. What's the big one? Sine squared
Plus cosine squared
equals 1. Okay, that's the big main one. Got to know that one. I got no special saying for that. What's the other one?
We got tangent.
1 adds a tan by the secant squared theta. All right, 1 adds a tan by the c. 1 adds a tan by the c. Okay, and what's the other funny phrase?
Co plus 1 is cozy.
Plus 1 is cosi. Cosi. Cotangent squared plus 1 is cosecant squared theta. Cot plus 1 equals cosi. All right. So again, we are going to be using these again today. I think on the back side of yesterday's worksheet, there might have been a couple of ones that might have been a little bit of a, whoops, what are we doing now sort of thing.
1 plus sine.
So you'll see some more of that today. I think I even do one of them today in notes that was on that one. So hopefully you'll see that. All right, so today you're actually going to see identities to start. So on today's worksheet, you're actually verifying the identity. So you're going to see something like this. We're actually given an equation that says these two things are equal to one another. Your job is to show us the steps of how we transform one side of that equals into cosecant. All right? It's not an equation. We're not solving for x. We're not doing anything like that. You're ignoring one side. The nice thing is it gives you a goal. This is what we want our final answer to be. And your job is to show us all the algebra that gets us there. Okay?
On the worksheet, is it going to give us that equals?
Cosecant t, yeah.
Cosecant. Give me You got a shiny.
All right. So again, our job is to really just look at one side, and I'm usually going to start with the side that's more complicated. So this left-hand side is definitely more complicated. And when I look at it, I see sine, cotangent, and cosine. That's 3 trig functions, and that's too many. And so a good strategy is to rewrite in terms of sine and cosine. So rewrite with sine and cosine because 2 is better than 3. Sine of t is already there, so I'm going to leave that one alone. But I can change cotangent of t. What can I change cotangent into? Cosine over sine. Cosine over sine. I think I heard 1 over tangent, and that's true. But I want to use sine and cosine. 1 over tangent doesn't use sine and cosine. So I'm trading out cotangent for cosine over sine. This is times cosine of t. And I'm going to leave that one alone because it's already sine or cosine. Now, you can think about this as we're multiplying 2 things together. These would be a fraction that we're multiplying together. And I'm going to clean that up. So I have sine of t plus, what do I get when I multiply my fractions together?
Just 1. No, 1 over
cosine t squared of t over sine of t. Okay, that's excellent. And now I have a fraction plus a fraction. And what do we need in order to add fractions? common denominator. So I need to multiply my first fraction by sine of t on top and bottom. And multiply top and bottom by sine of t. Now that gives me a lovely common denominator. So I'm just going to write that one common denominator and then look at my numerator. Sine times sine is sine squared of t, big plus sign. Cosine squared of t. So that's my numerator. And now I see something that is squared. Sine squared plus cosine squared equals 1. That is our Pythagorean identity. Really important to know that sine squared plus cosine squared is really just a 1. And so I have 1 over sine of t. And what is 1 over sine of t? Cosecant of t, which matches what we expected it to. So that's our job, is show all the work for just one side, and you should end up with cosecant of t is equal to cosecant of t, and that's the proof, essentially, is what we're doing. The algebraic proof of how we transform one side into the other, okay? Do you have any questions on those? A lot going on there. All right, let's look at another one. So Pythagorean identity. Be nice. All right, sorry, these are a little bit compact because I didn't realize what I was doing when I wrote the notes. So factor, then use identities to simplify. This is sine of x cosine squared of x minus sine of x, and it's supposed to equal negative sine cubed of x. That's what that says. I don't know if you can see that very well, but I apologize.
It's all right.
Thanks. So you are going to be doing a bit of factoring. And factoring comes in a lot of different forms. So we can factor, we can look for a greatest common factor. That's always a really, really good one. GCF. We can factor by double bubbling. Always a good option. Okay. All right. So again, negative sine cubed of x. That's what that says. Okay. So again, this is our goal, negative sine cubed of x, and I'm going to just work on this more complicated side, the left-hand side here. When I look at sine of x times cosine squared of x minus sine of x, I see two terms, 1, 2, and they have something in common. What do they have in common? A sine of x. Yeah, there is a greatest common factor here that we can take out. So I am going to undistribute the sine of x. What is left behind when I take out the sine of x? Cosine squared of x minus 1. Very good. Okay. So I heard that's a... It equals. This is tricky. It's something squared, and it's with a 1. So I'm thinking that it's a Pythagorean identity. Is it sine squared of x?
Yeah.
I mean, it should be.
It's negative sine squared of x. Let's look. Sine squared of x plus cosine squared of x equals 1. So order is important. This is cosine squared minus 1. So I'd actually need to move the 1 over to get cosine squared of x minus 1. And then we have to move the sine to the other side to isolate it. So that becomes negative sine squared of x. So we can trade in the cosine squared of x minus 1 for negative sine squared of x. Times that regular sine of x. Out in front, what is negative sine squared of x times sine of x?
Negative sine is 3.
Oh, no way.
There you go. Yay! Negative sine cubed of x equals negative sine cubed of x. Yay, we did it. Congratulations. You found the path to the treasure.
Oh, don't you mind.
Is this just like proofs?
It's proofs. Yeah.
Oh,
I could not do this.
Yeah.
Show proof.
I
Show
could
proof.
not do
It's proofs, but there's not
I
like
got, like,
80
Show proof
proofs.
that you hate proofs.
It's proofs, but then should I call them proofs? It's not like
It's proofs without calling them proofs because nobody likes proofs.
you would have called
Yeah.
them proofs.
Just color like proofs.
Yeah.
Okay.
I feel like if you
Dang, good for her.
Okay. Letter B. We have 1 minus 2 cosine squared of x plus cosine to the 4th of x. And it's supposed to equal sine to the 4th of x. Again, our goal is sine to the 4th. That's nice and simple. Over here, much more complicated. I see 3 terms.
Cosine squared of x. Take that dang out.
I can't take it out of the first thing, though. There's no GCF. This
Just subtract that
double
one then.
bubble.
Subtract that one.
No, you can't. We're not solving equations, so you don't move anything to the other side. Yes.
Put the one into the sine square of x plus cosine
Well, you could put it into. You could trade out the 1 and you could replace it with cosine squared plus sine squared. You could do that. So you could do that. Here's the problem with these identities is that there are like a million different ways we could solve them, and maybe your method would work. It'd just be a lot longer and a lot harder.
Good job, Sam.
But you might get there. All right, so it's definitely a possibility. We can also take out this cosine squared of x and replace it with 1 minus sine squared. All right, so there's a lot that you could do. But I see 3 terms, and it's quadratic in form, so it actually factors. What times what gives us 1?
1.
1 times 1 gives us 1. Last times last has to give us cosine to the 4th. What times what is cosine to the 4th? Cosine squared times cosine squared. And I heard a negative. We do need them to be negative. Where does this negative 2 cosine squared come from then?
There's a 1 squared, but
Yeah, the rainbow. Check the rainbow. Remember that?
Oh yeah.
Oh, yeah. So negative cosine squared of x and another negative cosine squared of x is where we get the negative 2 cosine squared of x. So it comes from the rainbow, checking the rainbow. Now, we factored that great. I'm seeing ones with things being squared. That's a Pythagorean identity. What can I trade 1 minus cosine squared for?
Negative sine.
Sorry.
Sine squared. Not negative. Why?
the order.
The order. Yeah, this is a positive cosine x and a minus 1.
Oh.
Yeah. All right, same thing. 1 minus cosine squared gets traded in for sine squared of x.
What?
Oh my god.
What is sine squared times sine squared?
Sine for x.
Sine to the 4th of x equals sine to the 4th of x. Yay!
That's what I call proof.
That's it.
Sometimes in life,
You do need to see it.
life
Once you see it, it's like, oh yeah, that makes total sense. Yeah. All right, I have one more for you. Not only one more, but one I want to show you. 1 minus cosine squared of x over 1 plus cosine of x. You're gonna see this on your homework, so I want to just throw this in here. It's sort of a different factoring method. Well, it's factoring. You'll notice we've got cosine being squared. And here we don't. Well, this is difference of squares.
Bless you.
It actually double bubbles. What times what gives me 1? 1 times 1. And last times last has to give me negative cosine squared. What gives me that? plus cosine of x and minus cosine of x. So this is difference of squares, and that's always going to factor. And when I have 1 plus cosine of x,
Cancel. Oh my god.
yeah, so factor and reduce is another method that you get to use. So anytime you see things that are squared, but underneath we don't have it being squared, you might try factoring, okay? So these reduce to 1s, and we're left with 1 minus cosine of x, okay? So you'll see that today in the homework. In fact, that might have been one of the problems, I don't know. All right, so factoring, GCF or double bubbling, good to think about. We got one more here.
Oh.
Hey guys.
I gotta be going.
Fooled you. Okay. All right, this one was, I'm pretty sure this was on yesterday somewhere.
Oh, that
Oh, that one. You had a few like this. Example 3, perform the addition and subtraction, then simplify. So again, what's nice about verifying identities is that they give you the result. We're trying to get to secant of theta. And so again, I'm looking at this more complicated side and figuring out how I can consolidate it. When I'm looking at this left-hand side, I see 3 trig functions. I see a tangent, a cosine, and a sine. And so what am I thinking about doing first? Yeah, trading the tangent in. What can I trade tangent in for? Sine theta over cosine of theta. Good. Very good. Because just 2 trig functions is better. Now we are adding fractions. What do you need in order to add fractions? Common denominators. So I have this denominator of a cosine of x. I have this denominator of 1 plus sine of x. What does my first fraction need? 1 plus sine of theta. I said x before. Sorry about that. All right, so that first fraction, top and bottom, we need 1 plus sine of theta. What about our second fraction? What does it need? Cosine of theta on top and bottom. I do encourage you to smush it in there. Smush it. Okay. Sorry. Now, my denominator is a lovely common denominator of cosine of theta times 1 plus sine of theta. So numerator is the tricky part. What do we need to do over here with this numerator? Distribute. Yeah, multiply that together. Distribute. 1 times sine of theta.
Sine theta.
Sine of theta. Sine times sine.
Sine squared theta.
Sine squared theta. Plus cosine times cosine.
Theta.
Cosine squared theta. All right, what do you see now? Pythagorean identity. Sine squared plus cosine squared is 1 plus sine theta over my denominator. All right, and then what do you see? Yeah, sine theta plus 1 over sine theta plus 1 reduces to 1 over cosine of theta, which is
secant.
Secant of theta. Yay for us. Good job. Okay. Do you have any questions for me? We're going to do one more together once I pass out the homework because it's a little bit weird.
Got us again.
Okay. All right, you have CP31. Oh.
Louise, I want another cookie.